Ah, yes, I know that issue.
Would you like to start this one, Bob? As I don't have the full context here yet.
Okay, so the issue that Marco linked for us to mention is like we've got a lot of services that are actually shards in so a service versus shard. A good example is Sidekick, and Sidekick we've separated the workload according to different characteristics, and those are different Sidekick shards. Marco has done a lot of work to improve alerting and observability of individual shards. So for example, if you open up the Sidekick main overview dashboard, you can now select one or more shards to view and then view a single SLI definition for that shard or multiple shards together. Before we had to do like we would only see the aggregation on the dashboard, but now you can see it separately. We would already have alerts per shard, I think. Did we,
Can we
Marco?
get a quick demo of that? Sounds
Yes.
like a demoable item for a demo.
Yes. But Marco put it on the agenda and then threw me under the bus.
No, it was that thing already demoed a few months back
Bob,
when.
you've never done that to anybody else ever.
Yeah.
Demo.
So the Sidekick dashboard, the way it looks now. It's like this. We're looking at the catch-all shard that's selectable here. We've got saturation by shard here, and then some SLIs here, for example, LLM completion, and the external dependency SLIs are always global. That's a setting, and let me maybe show that in the code next to this. So you make the shard. Yeah, you enable this whole thing by setting shard level monitoring true on a service definition, and then you can disable it again for certain SLIs. For example, this one doesn't use shard level monitoring. So when we're looking at these things here, the SLIs that are like Sidekick execution that are sharded, we're going to see just that shard, and that's going to be
Is there a visual indicator of the global ones versus non-global ones?
that's what I was thinking now. I don't
A
think
quick way is from the legend. You can infer from the legend. It's a very
yeah.
minute.
Okay,
So
so
in the legend there's a
global.
catch-all shard over
Okay,
there, but
yeah,
not
okay.
for the global ones.
Yeah.
Yeah.
So yeah,
A nice small change to make it a bit more
visible.
Yeah.
So yeah, the queries are separate. The difference is, yes, here you can catch all shard updates, and here it's just LLM completion
Gotcha,
updates. So that's
yeah.
the difference. But yeah, so we've got Marco built all of that, and that went surprisingly smooth. This meant that for Sidekick, we went away from having an SLI per shard to having two SLIs that apply to all shards. So Sidekick execution and Sidekick queuing is now separate, and yeah, you can. Let's pick one of the troublesome ones. So sometimes, for example, this one.
Yep. That one.
Didn't realize authorized projects has its own shard now.
It's we didn't want to call it quarantine, but it's basically that. So yeah, those can now be separated. This is like preliminary work for all these things should go away. For an issue that I created a while back, where we've used this pattern of creating either an SLI or a separate service several times. For example, we've got a bunch of databases that are actually shards, but yeah, we've got that for Redis. And if you think about it, the services we have that run GitLab, the Rails application and serve requests are also kind of shards. So this is an issue to start a discussion on which things should we label shards and observe them like that, and which should we keep as separate services.
So I guess the first question is, do all of those, with the Sidekick example, they all have exactly the same SLIs. They're kind of and I think the original thinking around a shard was really kind of like a horizontal or a vertical partition of the same data. So I think like Giddily was the original case, right? Where we were effectively quarantining problematic repositories and marquee customers into different shards for various reasons, historical reasons at the time. But with the Sidekick, sorry, not with, and then Sidekick sort of followed on because it made sense.
Did I freeze or did everybody?
Around GraphQL, for example, for the API. Was I frozen there or was
No, I think it was me.
Just checking. Okay. The with the API, I think they've got different SLIs, and for that reason, I think that would mean that they're not the same thing. And so for the rest of them, like for the Petroni ones, are the SLIs the same? And if they're not, can we make them the same? But if they're not, then I don't think that they should be shards. It's kind of my initial impression.
So where does that leave? Because right now we've solved that same SLIs thing with archetypes in a lot of the cases.
Yeah.
So
and archetypes aren't really like it's just sort of like a basis for generating like JSON, right? It's not, they don't have like a common relationship in the observability side. I don't think.
Right. It's basically a template.
Yeah. Yeah.
Like,
could actually just be called a template if you wanted to be simpler. Yeah.
I like the way you mentioned, like if the SLIs are exactly the same for all of these things, then we might want to start using a shard. I don't know if we're actually going to do any of those migrations, but for the future we could take it into account if we add more Redis or add more. Yeah.
With Petroni, going back to the case of Petroni and Petroni CI, my gut feel is that they probably do have the same SLIs, and maybe they are shards, because they are literally the way we do Sidekick, and we've partitioned traffic between Sidekick is pretty much the same concept as the way we partition traffic between the two Petronis, right?
One concern I have for something like Redis, because for each Redis shards that we have, they fundamentally have different type labels. So whereas in Sidekick, we already have the same type labels for every shard. So I wonder how
yeah, this would require
practical.
changing that.
Yeah, it's a breaking.
Yeah.
Yeah, I think the best way to do that would definitely be to change the labels if we did that. Although there's kind of like an operational component to that as well, in that for alerts and stuff, I think a lot of alerts are kind of grouped at a global level and not at a shard level for those services. And so at the very least, there'd be an educational aspect, particularly with the reliability teams who are on call, who would need to know, Redis is burning, which Redis shard is it? That sort of side of it would be an important, basically the on-call engineers would definitely have to be stakeholders in this whole process and this decision, at the least.
Right. I think I'm going to move some of the things we said here into the issue. and see if we move it forward. Thanks. I don't have the agenda close anymore. Igor, are you next?
Yeah, I'm up next. So we talked about this last week already, and I just wanted to give another update with some pretty nice results. So as a quick recap, this is the issue. There was a growth trend in shared state Redis that we discovered, non-critical, but still kind of interesting and perhaps worth taking a look at. And one of the things that we did was develop, where is it? Here we go. Develop a tool to visualize Redis space usage from an RDB dump. So basically convert an RDB into a flame graph. This was the flame graph that we had a previous version of this flame graph. And we can see, yeah, go ahead.
No, I just think that's so rad.
Yeah. Yeah, so we've got it grouped by type as well. And there's, sessions in there, which is fairly expected. There's the Gitly pushes since last GC tracking,
Don't
which
we have
is
a
pretty
separate
big.
Redis for sessions?
That is a really good question. Yeah, okay. I'm going to take a look at that right after this call.
Yeah, be careful because we also store session information that isn't the session, and maybe it's that.
It could be that. Yeah. I'll take a peek. That's a very good point. Hadn't occurred to me at all. And then we've got hash, which includes seemingly random stuff like tier badge, logged out marketing header. Took me a while to figure out what this is. It's actually GitLab experiment. And Marco and I created a spreadsheet and basically went through all of these keys to figure out which of them are still in use. And I think it was like 3 or 4 of them. So this is sorted by size of the key descending. This was the really big one. This was like 4 gigs. But then all of the others added up were like another 2 gigs. So yeah, there's a few in there, and some of these actually should be cleaned up. So there's a few old ones in there as well. And I think there's only 1 or 2 active experiments that we still need the keys for. So scrolling back up. Yeah, this was from deleting that first key. So going from like 14 gigs to it was like 9. And then let me show the savings first. Yeah, so we can see it here. So this is the first drop, and here's deleting those remaining keys. So that's nice. But this doesn't really answer the original question, right? The original question was growth trend. And Matt went ahead and did that analysis, which we can use the same tooling for because there is this thing called differential flame graphs. So if you have 2 folded output files, you can feed them to differential flame graph tool, and it'll give you the difference between the 2. So here's 2 RDB dumps, I think 1 week apart. And from just looking at the flame graphs themselves, it's a little tricky to tell the difference here. Like visually, can't really tell. If I open both of these up, let's see, 1, there we go, 2. So, like I can sort of move between the tabs and we can see, okay, there's like something here, and like this is maybe getting a bit bigger, I think. but it's hard to tell visually. And so using this diff folded command, side note, Inferno is a rewrite of the flame graph tools in Rust. And for some of these larger files, it's a lot faster. So that's a neat thing to be aware of. But yeah, here's the differential flame graph, and here it's really obvious, right? So yes, we see growth in tier badge. Tier badge is one of those GitLab experiment keys. And there's a bit of a growth in the Gitly tracking here as well. So yeah, conclusion, this is an experiment. It's bounded by number of total number of users. I guess the largest it can get is probably something like this logged out marketing header would be my assumption. And it'll get cleaned up eventually. So not really any action we need to take at this
I
time.
assume it's going to be cleaned up eventually, but last time we didn't, apparently.
Yeah, so on that note, I did open 2 issues with the growth team who owns the GitLab experiment gem. First one is to do exactly what you just said, which is actually clean that stuff up. And the team is discussing a few options here. So either integrating with ChatOps or have post-deployment migration. I'm leaving it up to that team how they want to handle it. Any of those is fine with me. So hopefully that will ensure that it will be cleaned up going forward. And then the other one is adding some kind of key prefix, because it was really hard to tell where this stuff is coming from, because the keys were just top level. And tier badge, I don't know what that is. So yeah, I think this will also make just categorizing that stuff a little more straightforward, and also help with attribution in general. So yeah, I thought this was pretty neat, and it's kind of cool to see how versatile this flame graph tooling is. It was not that hard to implement, but we didn't have this type of analysis before.
Maybe it'll help demonstrate a little bit. I've always piped something into FlameGraph PL, but I don't actually know what the format of what you put into the FlameGraph is. Could you just show? Could you show? Is it complicated?
Sure. I don't know if I have one lying around.
What is it, JSON, or what is it?
No, it's text-based. It's
Okay.
I can just type it out. I mean, it's a pretty straightforward format.
That's a great idea, using a flame graph.
I mean, it's basically
okay, and then a value. Okay.
Yeah, and so I mean, we can actually do it right now. So this pipe into flamegraph.pl. And then usually I put hash to get consistent colors. And usually I do colors Perl, which in this case won't make a big difference, but can be nice. So flamegraph.svg. I need to actually quote that. Okay. And so let's open that up, and then you just get something like this.
And so multiple lines will be multiple
yes.
stacks. Yeah. Okay. Awesome.
And yeah, and they get summed up together. So,
right. Okay. Oh, so it does the aggregation of the base layers.
Yeah. So we do A, B, C. A lot.
Yeah.
And then we do B, C, D, something like this. Okay. Go back here. And yeah, so we've got ABC, which
Okay.
has a lot. And then we've got CD, which was a smaller sample. And then we've got this other stack here. So yeah, I mean, it's
to know.
it's a
Yeah.
really simple format. And so it's also easy to take, you know, whatever existing data you have,
Yeah.
replace things with semicolons, which is what this tool is doing effectively. And yeah, then you pipe it into that script and you get fancy flame graphs.
That's such a great idea. Such a good use of, or such a good way to visualize the Redis data.
Yeah.
Awesome.
Igor, how did we find out last week? I wasn't here last week. You mentioned the growth trend. Was that coming from capacity planning, or did we notice that elsewhere?
No, I think Matt Smiley noticed that originally. And yeah, then Matt and Marco were kind of curious enough to poke at it. We still have quite a bit of capacity headroom in terms of memory, so that's probably the reason why it wasn't yet showing up in capacity planning. My expectation is, had this trend continued, it eventually would have.
And I was wondering if we have a way to detect that earlier, so before saturation goes up. So, and without anybody looking into that, but it's probably difficult to do.
No, this is memory consumption. We've got saturation points for that. So
Sure, yeah, but could we have done that automatically without us looking into it for this one?
We could have waited, and then capacity planning would have told us.
Okay.
So,
yeah.
yeah.
Should we be keeping those, those two differentials that you used? Should we be snapshotting those somewhere and keeping them over a longer term so that you can see longer term growth analysis?
Yeah. So yeah, I did open some follow-up issues. The first one just to document this new methodology, and the second one to potentially automate it. Yeah, I think it would be cool, especially if we can also make it available to other teams and stage groups and kind of let them see how their usage is growing over time. Yeah.
That's a great idea.
So with those changes, with that space that was reclaimed on Redis persistent, what is it looking like now in terms of how urgent it is to deal with this one for saturation?
It wasn't urgent to begin with. It's even less urgent now. I think memory usage was around like 25%, and now it's like 15, something like that. So yeah, urgency generally fairly low, but I think it was still worthwhile to actually develop this tooling because we can use it for any of our Redises going forward.
Also, I think, to me, the most important artifact was the fact that the team that was leaving the stuff around is building a process to clean up after themselves. I think that's more important, because 5 or 6 experiments down the line, it would be harder to untangle all of this.
Yeah, I mean, basically, if we hadn't done this now, then those keys would have kept growing over the next 2 years and probably become critical at that point.
Yeah. The key, like the biggest one that you removed, wasn't growing anymore, I think. It was just
but we're adding new experiments.
Yeah, there'll be more of those. Yeah.
And then they would be harder to recognize each time because they are not prefixed. And
yep.
I just pasted from Tamland the Redis memory forecast, and it's on the agenda. So the last 2 drops is what we're seeing there as well, right?
Yes.
Nice.
So which Redis instance is causing us the most concern now?
So I mean, this was Redis memory space in particular, which is something that we haven't actually been too concerned with on most of the Redises. It's been more CPU.
Mm.
Um,
I'm asking from the context of like I'm busy looking at OKRs for the next quarter, and I'm trying to figure out if any of
I
them
think
need
it's still
link to Redis.
the shared state, so persistent.
in terms of CPU.
Yeah, it's still on top of for Timeland, but we did some work there, so I don't know where we're going to land now when Timeland's just the forecast.
Yeah, we're also moving that over to cluster, hopefully fairly soon. I think there's been lots of preparation work happening for that. My current view, I think we need to confirm this, is for Q4, we're hoping that once we've moved shared state to cluster, there won't be any imminent saturation concerns. That's definitely to be confirmed. I think we then need to make a decision with Redis as to what we do next. Do we kind of put it on hold for other priorities, or do we start to look at how we increase clusters, because we haven't done that yet, like the resharding process, or do we think we have enough headroom that that's not urgent and we can kind of delay it until a suitable point in the future? So I think that's a question that we need to answer over the next week or so to inform the OKRs.
I think
Yes, please.
that goes into Igor's next point, but I think the next Redis we would have to, like, we would want to look at is probably Redis Sidekick.
Yeah, which is its
I
own
don't know when the
challenge.
baseline is currently, or it's like around 50%, but we don't have a plan yet. So we can't just throw Redis cluster at it. So we need to think about something different. Igor,
Yeah.
you want to take it away?
But just one thought before we get into that. I guess since we've migrated so much stuff to Redis cluster, that's brought us not only immediate headroom, but also growth for the future, and sort of alleviated the need for us to really make too many plans on most of our Redises.
No, that's good.
And
Because for the context for asking the question is that I've also asked Bob to take a look at what does the overall system headroom look like for GitLab.com. So we could give that as a a couple line statement to the higher up stakeholders that just say these are the areas that we are not worried about anymore, and these are the areas that we are. And I think since there's been such a high focus on Redis, there would definitely be one of the questions that comes up is, and what about Redis? So at least if we have an answer for that, it's really helpful. So thank you.
Can I just ask a follow-on question? With the Redis saturation metrics that go into Timeland, when we move to cluster, did those ones get updated in the saturation framework to be horizontally scalable equals true?
I believe so. Yeah.
They did, okay. So they are considered, they're not, yeah, they're like a lower priority rank already. That's great.
Okay. So I'll take the next one. This is really kind of a short item since we talked about this two weeks ago already, but there's Sidekick functional sharding v2 proposal that I initially put together, and we did discover a few caveats here. In particular, the Sidekick API stuff. So whenever we're interacting with Sidekick queues, and so that includes various like management tasks. That was previously not, I guess, not shardable, not shard aware. And so it would have required some monkey patching or other workarounds to get working. However, I did some research, and in Sidekick v7, they introduced this idea called capsules, which sort of encapsulates the Sidekick config and context to be kind of thread local as opposed to process global. And that allows us to override values within like a thread and also within a Ruby block. And so there's this thing called Sidekick client via, which that API already existed. Here's an example of that. So you can basically say, within this block, I want to use this Redis pool instead of whatever the global one is. Previously, this only worked for Sidekick client, so only for effectively perform async and schedule at, or whatever it's called, or perform in, was it? Yeah. Anyway, the internals have been reworked, and this now actually works with Sidekick API as well. And let's see, I opened an upstream issue about this, and yeah, here's the example that was provided. So you can basically say via client, and then you can use the Sidekick API methods. So this opens the door for us using this stuff without having to monkey patch Sidekick at all. We just need to make sure that all of the places where we use the Sidekick API, we actually wrap it in one of these. And also all of the places where we publish jobs to clients, we also need to be explicit about this, because if we have consumers like Sidekick server processes, those are going to have their default Sidekick set to a specific shard. And we want to ensure that when we publish, we target the right one every single time.
Igor, could we not start by could we not start with basically having like a shard 2? So say we got shard 1 is our current shard, and then like as we migrate, you know, everything to this new Sidekick 7 via methodology, you can do it gradually, right? You know, with 90% of the, or 99% of the Sidekick jobs still happening in the main default cluster, but migrate things sort of piecemeal across. Like that would be one approach that you could do it sort of bit by bit. You wouldn't have to do it in a big bang and get everything at one time, right?
Yeah, it should be possible to do it incrementally, but there are quite a few things we need to get right from the get-go. Because if we end up like publishing to the wrong Redis, and then there's nobody actually consuming from that Redis, then
and would you imagine that every Redis would have the same work? So basically the queues that are connected to each Redis are identical. It's just it's like a random lottery where you end up, and then all the workers are available on all the Redises.
That's a good question. So I think it would probably be more like we assign a queue per Redis. So we say, for this queue, you always publish to this Redis. However, in order to get that load balancing that you're alluding to, where is it?
Yeah.
Here, yeah. So because when we do that, the issue is there's going to be like the default queue, and it's going to be the largest one, and it's going to yes, exactly. But then we can basically break up, specifically targeting larger ones, larger queues, break those up into smaller ones. And so using this producer side load balancing,
Yeah.
effectively, instead of publishing to default, we publish to default and then pick a random number, and then it'll balance between, and then we say default 1 goes to Redis sidekick A, default 2 goes to Redis sidekick B. And
you could weight those as well, right? It could be like
yes.
1 to 4 goes to default and 5 goes to this new little cluster that we kind of starting with. Well,
Yep.
Yeah.
Yes. Yeah. And so it's actually kind of similar to how Elasticsearch does its sharding, where you usually, when you insert a document in Elasticsearch, it gets assigned randomly, or it gets assigned a random ID, and then based on that random ID, it gets hashed into a specific shard. So it's sort of a similar idea.
Yeah. Awesome. That's really nice. That's really great that Sidekick is doing that now.
Yeah, and
I remember
I guess
a bunch of investigation before, and it was really complicated, and that's why we never went down that route.
Yeah, not having to monkey patch, I think, is that would be a huge win.
Definitely.
Yeah, that's all I had.
Okay.
Probably it.
Yeah, if there's nothing else, I guess we can call it a meeting. Thank you all so much.
Bye bye.
Thanks, Bill.
Have a good day.
Bye.
Thanks, everyone.
Cheers.